Okay. Sorry that took so long. I ran a little late, and then of course I had to run around and give everybody their stuff. But so determine whether the following data sets are linear. If not, say why. If it is, find the equation for P as a function of Q. So this first one here, we go ahead and change it. Well, it's going to be 2, and then by please correct my arithmetic if I'm wrong. My brain's all over the place right now. The mic is kind of going in and out. They supposedly give me this fancy headset. It's not fancy. And then it just doesn't end up working. Can y'all hear me now? Is it sounding a little better? Is it cutting out? Okay. I'm going to assume that you can hear me better. Okay, good. So we increase by 2, and by 1. And then our Q values are increasing by 4, 4, and 4. So remember, we need the change in Q over change in P. So that would be 4 over 2 versus 4 over 2 versus 4 over 1. So since those first two reduced to 4, but this third one is still 4, those don't agree. So this is going to be not linear. I should have written that over much farther to the left. Hello. Whoosh. And we can say slopes are not constant. Okay, so that's all you'd have to say for that. And then for this second one, we go ahead and check our little loops. So we've got increase by 2, increase by 3, and increase by 1. Increase by 4, by 6, and by 2. So if we compare the change in Q's over change in P's, we're going to have 4 over 2 versus 6 over 3 versus 2 over 1, which all reduce to 2. Yes, so they all reduce to 2. So that means the slopes are constant, so we do have a linear relationship. Now, I was a little tricky on this one because I'm asking for P as a function of Q, so we can't use this as our slope because it's the opposite of what we actually need. So you do need to be a little careful to make sure that so you can still use this as your is it linear or is it not linear. That's perfectly fine, even though it was in the quote-unquote wrong order for the equation that I'm asking, okay? So we can still use this value as our yes, it's linear, but now we actually need to go back and recalculate the correct slope for the format that I wanted in. So since I want P as a function of Q, that means that my P values are acting as my Y's, so I actually need change in P over change in Q as my slope. Well, I can take any one of these that I want, and just essentially flip it over. So say I take that first set, the 4 and the 2, so the change in P was 2 and the change in Q was 4. So I'm going to have that the slope that I'm going to work with is 1/2. Does that make sense? Okay. So the slope I'm working with was 1/2. So once I have my slope, I get to pick whichever one of these points makes me happy. No, that's not what I wanted to share. So thanks for sharing the wrong thing. Teams, can you hear me? I'm gonna assume that's a no. Oh, Jesus Christ. I literally don't know what to do about that.
We can hear you.
Can you hear me now? Teams, can you hear me now?
Yes.
Okay. So now I'm not only joined on the computer or desktop on my laptop, but you're on my phone now for audio. So hopefully it works. All right. So where was I? So we had our slope of 1/2, and I think that's about where it froze. So once we had the slope of 1/2, whoops, sorry, now I'm moving the screen. We want it to be written as P equals MQ plus B. And I decided to choose the 0.68. So I plugged in the 6 for the P, the 8 for the Q, and the 1/2 for the M. What up? Why didn't it matter for just the linear versus nonlinear? Okay. Specifically because I asked for P as a function of Q. So since I asked for it in a specific format, you have to have the slope fit that specific format. For the what is happening now? For the just generic linear versus nonlinear, Jesus. Sorry, for the generic linear versus nonlinear, it's not going to care which format we put it in. It's either going to be constant or not. But when I want to actually put it in the equation, if I specifically ask for one way over the other, you have to make sure you do it in the way that I asked for. What up? Yes. So if you've picked up on the fact that the slopes are turning out to be reciprocals, that's not a coincidence. It's always going to happen. So I tried resharing to try to fix that glitch, but just keep telling me when things aren't working. So okay, I'm not even done this question yet. Good Lord Almighty, and it's already 12:20. Anyway, so 1/2 times 8 is 4. Oh Jesus. Subtract 4 from both sides, you get 2 equals B, so you get P equals 1/2 Q plus 2 as your answer for that question. Questions, concerns? Okay. Why isn't it counting? I don't have time to, okay. I don't have time to worry about that. So no questions in Teams, it seems. No questions in here. So average rates of change for these two that we were requested of. Let me move this down so I actually have space to write the answer. Or not. Never mind. I'll just zoom in. Why is everything hating me today? You gonna move down now? Now, of course you. Whatever. Again, throw the whole thing out. So average rate of change between x equals 1 and x equals 9. But remember that the average rate of change is essentially the same thing as a slope. So we can calculate the slope between those 2 points. So I would do 15 minus 7, 1 minus 9. I did not think ahead of time for this arithmetic. That's 8 over -8. So -1. Cool. I love when things I just pull off the top of my head work out nicely. And then the average rate of change for 3 to 5 is, so 3 and 5. So 10 minus 3 over 3 minus 5. So 7 over -2, and that can't reduce, so just leave it. I mean, you can convert it to a decimal if you feel like it. Savvy? Okay. So for about 10 minutes, we'll do notes, which is 1-4. So we finished 1-3 the other day, and we're starting 1-4 today. I have to share that, Lord. So unshare this, and now share the notes. They are on Blackboard. They appeared last night. I guess that really only helps the people on Teams, but. So 1.4 is all about applications to economics, and this is kind of where we start getting into a bit more of, kind of the businessy side, and not really like super businessy. This is like baby business, but we touch on it a little bit. So we have that the cost function, which we use C of Q for, is going to give the total cost to produce Q items. And yes, we are almost always going to use Q when we are talking about these functions. Sometimes it'll use another variable, but most of the time it'll be using Q for quantity. There is fixed costs. And this is the cost associated with producing no units. So say you don't even make anything, you still have to pay the rent for your building, you still have to pay for the materials, you still have to pay your workers, all of those things that you have to pay for even if you don't get around to making anything. So those are your fixed costs. And then we have marginal, which are also sometimes called variable costs. And this is the cost of producing the next item. So essentially, say you're crocheting things, and the amount of yarn you use for each, I don't know, blanket you're crocheting, the amount of yarn you use is worth $2. So that means for each other blanket you crochet, it costs you an extra $2. So that would be the marginal cost in that scenario. So if cost is linear, it's kind of nice because the marginal cost is going to turn out to be the slope. And the fixed costs are going to turn out to be the y-intercept. Whoa, that got a lot louder suddenly. Now that's technically always true, except the slope, it gets a bit more specific when you talk about different types of functions. But the fixed costs being the y-intercept is true for absolutely any function as well. And once we get to more types of functions and we start bringing them in, we'll talk about how the marginal cost shows up, because again, it's in a slightly different context because there's no immediate slope to pull out. But if it's linear, you can just kind of look at it and say, what's the slope? What's the fixed? What's the y-intercept? That's my marginal and fixed respectively. So let me leave that up just in case. So let's say a radio factory creates radios for $7 per radio. So that's saying that it's costing them $7 to make the radio. It's not that they're selling it for that much. Labor and raw materials costs are $24,000. Find and sketch the cost equation for the company. Label the marginal and fixed costs on the graph. So we need so we're looking for a cost function. And now technically, this is bad question writing for me. I should say assume it's linear. Now that's the only function we have to work with right now, so that we were kind of jammed into there anyway, but I should technically say assume it's linear to do this function. So if it's linear, we're looking for some m cubed plus b. But if I use this idea that the marginal cost is the slope and the fixed cost is the y-intercept, kind of just falls out for me. So the fixed costs here are going to be that $24,000 because, again, no matter how many radios I make, I still have to pay that much money. So the fixed cost, so since our fixed is the $24,000, and then our marginal would have then, of course, be the only other number left, the 7. But again, since that's the cost, excuse me, that's the cost per radio, that wording also, excuse me, tells you that it's the marginal as well. So our cost equation here would be 7Q plus $24,000. Now say I want to sketch this, and because we're running short on time, it's going to be a sketch. In my other class, I made it a little nicer, but we're just going to sketch it. So if this is my quantity axis and this is my cost axis, well, again, the fixed cost is my y-intercept. Now, $24,000 is pretty large, so let's go ahead and put it, way up here. So this right here is going to be our fixed, or $24,000. Now, our marginal here, which is representing our slope, is 7. 7 is obnoxiously small compared to $24,000. So it's going to be a pretty almost flat looking line, right? Because the slope's going to be so obnoxiously small compared to the y-intercept. So, we're going to have a pretty, it still is rising from left to right, but just barely because the slope is so obnoxiously small. And if I want to demonstrate the slope, usually how we do that is we just draw a little, slope triangle, if you will. So this here would be slope gives the marginal. That makes sense? Because of all the hoopla that went on earlier, just so that we can get a bit more of the actual content in, I'm going to skip down to the next set of definitions, and we'll come back to this example that I'm about to skip in a hot second. So we'll come back to that. And I know I said that last time and then we never came back to it. We'll actually come back to it. But let's get some final definitions under our belt so we know a little bit more about 1.4. So the revenue function, why can't I? There we go. The revenue function gives the total revenue, and I know I used the word in the definition, but so it gives the total revenue received by a firm by selling a quantity Q of some good. So that's essentially, I sell 100 radios, I make blah amount of money selling them. That's your revenue. However much money you made just by selling those things. Now, one thing we're going to want to remember is that revenue is equal to price times quantity. Sometimes just referred to as P times Q. This is something you're going to want to remember. And then we have the profit function, which is represented by pi of Q. Now that pi there is just a symbol. It's not representing the number in this case. Why do we use pi? I honestly don't know. I think it's to avoid using P of Q because P is usually used very often in probability. So I think that's why they avoid it. If you prefer to just use P of Q, I'll understand what you mean. So if you want to use P of Q instead of pi of Q, you can, but technically the correct notation is pi of Q. And we calculate profit by doing revenue minus cost. So the thing you might want to get in your brain is the symbol representation of that. Pi equals R minus C. Now you can also kind of talk yourself through that all the time. So if you think about it, the profit is the amount of money you get to take home to your mom and be like, hey mom, I made this much money today, right? And that's going to be based off of how much money you had from selling things, the revenue, but then you have to pay people or else they're going to get angry at you. So you take however much money you got from selling the stuff, pay the people you need to pay, and whatever is left over is what you get to take home. So it kind of does make sense, revenue minus cost, the amount of money you have in total minus the stuff you have to pay people. Just to get in one small, and I will go through this example again on Friday, but just so that you can see how this is going to work, I'm going to jump down to example 3 really quick, just so that we can find a revenue and profit function so you kind of see how it works. And then again, I will go through this in a bit more detail on Friday. So I just want to find number 1. So consider the radio factory from the previous example. If they sell each radio for $15, what is the revenue and profit functions? So to remind us, our cost function was 7Q plus $24,000. Our revenue function here, so again, this is price times quantity. I said you're going to want to remember it. Well, what's the price they're selling them for? $15. So here our revenue function is 15Q. It's that simple. It's not a trick. That's it. Price times quantity. Now for the profit function, well, that's revenue minus cost. And we have both of those two equations, so we just got to kind of plug them in, if you will. So our revenue function we just found was 15Q. Now the one thing you have to be very careful with, always put cost in parentheses. I'm just going to say always because it's better to just say always than try to figure out the specific cases where you need to do it. It's pretty much always. The reason for that is because we have to distribute that negative to be able to simplify it. So if you don't have it in those parentheses, you're probably going to forget to do it, and then you're going to get it wrong. So if you distribute that negative, you get minus 7Q minus $24,000. That's enough zeros. Which reduces to 8Q minus $24,000, which is then your profit function. They really are, for linear equations, they really are essentially that simple. And maybe I should avoid the word simple in case some of you didn't think it was simple. But that's how you do it. So now we know how to find cost, revenue, and profit functions in linear cases. Okay. And that's as far as we can get because everything exploded 2 seconds ago. So now what's going to happen is we're going to take our quiz, of course, unless there's any quick questions on this. Okay. So I'm going to stop the recording.